everyone. In our last video, we had discussed about the effect of temperature on equilibrium constant, and today I am going to talk about effect of pressure on equilibrium constant. So we know that the equilibrium constant K is related to the standard Gibbs free energy change, and this is given by equation delta G naught is equals to minus RT ln of K. And K is what? It is an equilibrium constant, and which is given by if you have reaction, simple reaction BB, and it gives you product CC and DD. Small letters represents the stoichiometric coefficient and capital letters represents the components. Okay, so you can write equilibrium constant in terms of activity. So A, C, capital C, C, A, D, D upon A, and A, B, B. And you can write this summation of activity coefficient of all the component I present in the reaction and power of stoichiometric coefficient of component I, overall stoichiometric coefficient, right? So from this equation you can see the equilibrium constant, which is defined here, is independent of the pressure, right? And this equation, the equilibrium constant, is known if the standard free energy of the reaction and the reaction temperature. Standard K, how we can find out K? If standard free energy is known of the standard free energy of the reaction is known and the temperature of the reaction is known, then you can find out the equilibrium constant from this equation. Let's take, this is the equation number 1 and this is the equation number 2, right? And the standard free energy of a reaction is determined by the free energies of the substance in their standard state. The standard states are defined by specifying pressure and are no way affected by the reaction pressure. So that is the standard free energy of a reaction, and hence the equilibrium constant are not affected by change in the equilibrium constant. So effect of pressure on equilibrium constant is there is no effect of pressure on equilibrium constant. Now, though the equilibrium constant is unaffected by pressure, it does affect the equilibrium composition in gas phase reaction. So we need to discuss this effect of pressure on equilibrium constant. So except at very high pressure, properties of solids, liquid or solution are not affected by pressure. Therefore, the equilibrium concentration or the equilibrium composition in reaction involving solid or liquid are not affected significantly by change in pressure. So to predict the effect of pressure quantitatively, the relationship between the equilibrium constant and equilibrium composition must be established. So we know that the reaction equation, this is the equation number 2, right? So we can write equilibrium constant K and Kf, which is this is in terms of equilibrium constant in terms of fugacity, equilibrium constant in terms of fugacities of the component, and we have already discussed this, right? So it is employing ideal gas standard state. So we know that K is equals to summation of Fi bar nu I, right? And which is equals to Kf, right? Now let's take, this is the equation number 3, and we know that fugacity can be written as product of fugacity coefficient and partial pressure of the component. So we know that F or you can phi I bar is equals to Fi bar upon Pi bar, right? And therefore Fi bar is equals to phi I bar Pi bar, right? And now just substitute this Fi bar in place of equation number 3. So what we will get? We get K is equals to summation of phi I bar upon Pi bar stoichiometric coefficient. This is the equation number 4. And from partial pressure, we know that Pi bar is equals to YIP. And let's take this as the equation number 5. Equation number 4 and 5, what we have, K equilibrium constant is equals to summation of phi I bar YIP and nu I. Okay. And then summation of, you can write individually, nu I yi, summation of yi, nu I, this is summation, and p in nu I. And then K is equals to, this is what, K in terms of fugacity coefficient, right? And this is what, Ky, this is what in terms of composition, and this is P nu I. Okay, and let's take this as the equation number 6. Okay, now since we know that fugacity coefficient is 1 for an ideal gas, so in case of for an ideal gas, K phi I will be equal to 1, then K is equals to Ky P stoichiometric coefficient or overall stoichiometric coefficient or nu. Okay, and this is our equation number 7. So since K is independent of pressure, variation in P nu from equation number 7 must be balanced by corresponding change in the value of Ky. Okay, so if number of moles of any reaction, right, decrease, then stoichiometric coefficient will be equal to, क्या हो जाएगा, it will be negative, and then pressure will be rise, and if pressure will be rise, then P nu will be decrease. Okay, and if number of moles of any reaction, if number of moles N increase, okay, then nu will be positive. If nu will be positive, then pressure will be, from this equation, right, then pressure will be decrease, and pressure will be decrease, then P nu will be rise. So from this equation we will get, if this is the effect of pressure on composition, right,